sign so we could get this party started. So thanks for coming. Am I audible? Awesome. So in Brief History of Time, Stephen Hawking writes, a well-known scientist once gave a public lecture on astronomy. He described how the Earth orbits around the sun, and at the end of the lecture, a little old lady in the back of the room got up and said, "What you have said is rubbish. The world is really a flat plate supported on the back of a giant tortoise." Well, the scientist gave a superior smile before replying, "What is the tortoise standing on?" "You're very clever, young man," said the old lady, "but it's turtles all the way down." So I relate that story, which many of you have probably heard before, because I think we're in a very similar position when it comes to storing secrets. And that's credentials, keys, and the like. We can encrypt them, but we need somewhere to store the key. We can encrypt the key, but we need a way to protect that key, et cetera, et cetera, et cetera. At some point, we need human intervention, but humans are forgetful, unreliable, and prone to being run over by buses. As a former coworker of mine says, everything goes wrong as soon as you enter meat space. So we have to try to balance these concerns. So today I'm going to talk about the need for secrets, the kinds of problems that secret storage creates, tools and approaches to help you solve those problems, and ways of thinking about them to help you decide what will work best for you. Given that list, I'm also going to talk about them really fast, because that's a lot of things and at a pretty high level. So, quick note on who am I and why you should believe me. I'm a consultant and technical lead at ThoughtWorks. I write code and lead teams who write code. I'm also involved in a group at ThoughtWorks who helps develop and improve our secure delivery practice, as well as doing customer and consultant training. I started this research because I didn't like what I was seeing. I didn't like the way secrets were being handled in many of the organizations I worked with. Sometimes it was the Wild West. Sometimes an organization prioritized security, but at heavy expense to automation and repeatability. Sometimes a very complex series of data encryption protocols was accompanied by a complete lack of key management strategy. I expect many of you have seen that before. And sometimes there was zero auditing. So a couple of caveats. I come from the development side of the house. I'm not a pen tester, so when I talk about some of these tools, caveat emptor. My focus in the research was also primarily on usability, ease of integration, and operational viability. Security is, of course, what's driving all of this, but this is coming more from a development perspective. Because I won't be able to cover this in enormous depth, I'm working on, it's very much a work in progress, but a companion site. And I tested a number of products for deployability and developer friendliness. I built a little kind of hello world-ish dummy app and deployed it via chef cookbooks to Vagrant apps and to get a feel for the apps. On the companion site, you can see my raw notes at this point and some write-ups, the criteria I used to evaluate, the app I built, et cetera. And a caveat on that, don't necessarily use those cookbooks as a model for deployment in your production environment, because I took a lot of shortcuts, checked in things that you don't want to check in. I tried to annotate that, but be warned. So I think it's safe to say that just about any meaningful web app on the planet has some kind of secret associated with it, whether it's database credentials, SSL certificates, private keys for signing and decryption, et cetera. And these secrets need to be protected and they need to be deployed. And at the same time, we don't want to return to the bad old world where there's a single machine sitting in production with a 5-year-old password that's only known by a single DBA, and it has to be edited by SSHing in. I'm probably speaking to the choir. I'm hearing this theme a lot this year, which is great. Or we don't want to return to the world where passwords are the worst kept secret in the company. And we aspire to repeatability, reliability, and self-service. And so all those principles of continuous integration, continuous delivery that we value needs to live alongside and be balanced with our security. So I'm approaching this a little bit from the perspective of where you go kind of depends on where you are. So when I started this, I had very lofty ideas about sort of what perfect looks like. And I thought back on my experience and have come back from that a little bit. And so you're going to find that I've staged this in terms of, okay, if you're here, you may want to think about this. If you are a little more advanced, you may want to think about this next stage, or turtle as I've dubbed it. So the first step is, of course, setting goals. What is your first level goal so you can start your iterations? And not everyone, probably every company is going to have a different set of goals, and that's a good thing. But I'm going to take a reasonable stab at a set of goals to start with. I think the idea of secrets being secrets is probably not a terribly controversial idea. Auditing. The importance of auditing is often overlooked in the organizations I've worked with. Again, that's another theme I'm hearing a lot here this year, so that's great. And auditing does not mean dumping something to a log file and then never looking at it. I have a personal predisposition toward transparency. And what I mean by that is that in the security business, there's this tendency to value secrecy. I mean, this, after all, is talking about storing secrets. But I would prefer a world where there's a great big radiator, like in the main hall, that shows every time a secret has been accessed. Maybe not the secret itself, but access should be audited and, if possible, published. And finally, or not quite finally, penultimately, not having secrets be the sole domain of a single person because of that whole run over by a bus problem, or as one of my coworkers likes to think of it, as wins the lottery and quits. And finally, standardization of practices. You're going to probably have to build some of your own stuff, but the more that you can use that's existing and proven, and that means protocols, algorithms, et cetera, it also means not downloading just everything off GitHub and assuming that it's battle-hardened. We're seeing that as well, too. So alongside of those, you're going to have your operational goals. For example, I want deployment of my secrets to be automated along with everything else. We don't want this to be the one break in the pipe. Operational requirements, auditing, access, et cetera, may be a little different, but we should aspire to the same degree of automation that we have for all our other resources, maybe even higher, as well as what I call, with some trepidation, scaling operationally. And I mean something very specific by that. I'm not talking about performance and can I scale horizontally across multiple machines, although that is obviously important. I'm talking about having a starting place from an investment perspective. If I have one kind of medium grade secret to spare, do I have to spend $1 million to know that tomorrow I'm not going to be completely hamstrung? And so I think it's important to have a strategy, or more likely a set of strategies that will accommodate growth. So all of those goals should be accomplished by whatever you deliver being easy to use. And I see us often creating the sticky note on the monitor problem. And if people are circumventing my security measures, then I'm really wasting my time. So I don't want to overstate it. Security requires discipline. It requires you as an organization trying to build that security culture so people want to do the right thing, and they're willing to at least take a little bit of a step out of their way to do it. But there's no faster path to failure than having your security controls prevent people from doing their jobs. And so this is why that usability is often a focus in the analysis I've done. So, find my water here. So at some point in the evolution of this slide deck, turtles became more than a symbol of finding ways to hide keys. It became sort of a metaphor for finding the kind of security where you have achieved the ultimate balance with usability, and that your security practice doesn't interfere with your automation and vice versa. But you're not going to be able to get it all in one go. You're probably never actually going to reach that nirvana, but you want a path for continuous improvement and not letting perfect become the enemy of the good. So let's talk about where your organization might be and what kind of steps might get you a step better. So if this is the world you're in, and do not hang your head in shame if it is, but your secrets are checked into SCM along with everything else unencrypted. This is just a reality we face. If there's anybody on the top 10 list, like, I think secrets in SCM should be within the top 5. I see this so often, and it just pains me. But second, admins everywhere. Everybody is an admin for everything, because again, at the end of the day, you do have to do your job. Credentials are so operationally hard to acquire that people share them and reuse them. These are all anti-patterns of security, right? Secrets that aren't really secrets, kind of a corollary to the above, because again, everybody needs to do their job, and if this is what it takes, this is what they're going to do. So if this is the world you're in, the kinds of goals you're going to want to create are probably relatively modest, and that's okay. First thing you want to do is get those credentials so they're not sitting in SCM or in somebody's inbox or in the DBA's head. You want a way of controlling who has access to what, and ideally you have some sort of rotation strategy. That would be great. You want secrets to be deployed without manual intervention. And this is a very reasonable first set of goals. So again, no shame in being here. But how are you going to improve is the question. So I have sort of 3 basic strategies, pretty common, nothing terribly dramatic, but what I think are the most common are decryptor-based orchestration, so actual decryption on the orchestrator. And so I'm assuming, by the way, implicitly that the strategy is to encrypt your secrets and somehow decrypt them. I mean, it probably goes without saying. But second strategy is decrypting on the application instance itself. Third is what I've dubbed sort of, it's a little bit of a mouthful, but operational compartmentalization, sort of different pipelines for that meet in the middle. And some of these can overlap a little bit. So orchestrator decryption looks a little bit like this. So obviously you have some secret store, and we'll talk about the kinds of tools that could be. So say you're in an environment like Chef or Ansible or Puppet, or even you have a set of bash scripts. This, in effect, involves storing encrypted secrets, and perhaps with something like GitCrypt or something orchestrator-oriented like Chef Vault, and then decrypting the secret on the orchestrator and pushing it to the application over a secure channel. Those of you who are paying really close attention, probably, I could just wave my hands when I said secure channel and say, look over there, and then the problem's solved, but the problem isn't quite gone at this point. So there's an implicit advantage here, that this is a lot better than where you were before. So the better than nothing advantage. Secondly, from a key management perspective, it's a little bit of a straw man right now because I haven't talked about key management, but from a key management perspective, this isn't too onerous. You have a finite number of boxes. It's either your orchestrator or your orchestrator nodes that you're trying to manage, so not too painful. Your integration with your applications is probably not too painful, so if you have a lot of legacy and you can't afford to just rewrite everything and make it aware of your new security practices, this is not a bad first step, because you're going to be able to drop things on the file system and the apps can pick them up. Obviously, there's some disadvantages to this strategy. It's pretty heavy-handed. The severity of an exploit, for example, gets pretty bad if you're kind of putting all your eggs in one orchestrator. You don't have much compartmentalization. This practice encourages secrets being stored at rest, for sure. And finally, I say one more turtle, because we have not even gotten close to solving or even isolating the bootstrapping problem. You still need that secure channel somehow. How do you know that, imagine this is particularly true if you're on a shared network of some kind. How do you know you can trust the instances have been provisioned, or correctly provisioned, or that no one can grab your secrets off them, or even that your target node is what you think it is? And the answer in this scenario is, without layering something on top, you can't. Another strategy, very similar, honestly, is application decryption. You're doing basically the same thing, except your orchestrator becomes a conduit. You take your secrets, the orchestrator just passes it on, and they get decrypted on the instance itself. And not radically different. It does have a little bit of advantage from a compartmentalization perspective, depending on how you've sliced your keys. So for example, if you did this on a key per instance basis, which you could, you suddenly, if you don't trust the integrity of one instance, that doesn't mean you don't trust the integrity of everything that your orchestrator is deploying to. And there's some advantage there. Again, that integration is fairly straightforward. You're not going to have to rewrite applications. But this is sort of all the disadvantages of the last one, plus a lot of key management overhead. You're going to have to figure out how to bootstrap all these instances. And again, you're fighting with the secrets at rest problem. You haven't even gotten close to solving that. So, and again, you have your one more turtle. You have not solved the bootstrapping problem. If you look ahead, you'll find you never solve the bootstrapping problem. It is not a solvable problem, I would say. It's like the halting problem. All you can do is compartmentalize and isolate. So, speaking of compartmentalization, here's a variant of the strategies. In fact, something that can be kind of used with the other two. This is more an operational, organizational approach. Essentially different repos with secrets, and they meet at either the orchestrator, although I think more often at the application instance. And you have almost separate pipelines almost. Some advantages of this, same advantages before, easy integration process. You have clear responsibilities. If a key doesn't get where it's supposed to get, you know who to blame if that's your thing. However, this is a real kind of DevOps fail. I mean, I think dividing these things by your auditors will love this. They're like, oh, great, they're separate, perfect, you're golden. But this is a good way of creating organizational silos. And there's a sort of implicit lack of transparency. Unless everybody's sort of publishing radiators out to each other, my app's going to fail, my key's not going to be there, or whatever my secret is, and I'm going to have to struggle to find out why. So I've seen this done often, and often very, very badly. So be warned. The trust me, I'll upload the keys by the time you deploy to prod school of thought isn't one I'm real fond of. If you go this route, you want to make sure that all those secrets are deployed out of band. There's also they're in concert in some way. For example, you've segmented your pipeline, but they have a common trigger and they converge at some point, or else you're gonna get bit. So you look at the array of options you have before you, and you want to find some tools that are going to support those. And they can generally be broken down into 3 to 4.5 categories, depending. I'm going to talk about the first two to start. That's SCM encryption tools, orchestration tools, and we'll get to secret services later. There's also a fourth set that we're hearing more about, the secrets as a service. So that's things like Keybase. Maybe IAM roles fit into this category, but it's sort of the outsourcing of the management of the secret itself. I didn't really go deeply into those. I was more interested in the open source tools that would fit into a variety of infrastructures, because as a consultant, I find myself in a variety of infrastructures. But these are definitely worth a look, depending on the environment you're in, and worthy of a whole session or many sessions of their own. So SCM encryption tools, that probably most of you, if you're familiar with these tools, you're familiar with this category. It's probably the oldest, most mature category. It allows you to store secrets in Git, SVN, or the like, but encrypted, generally with an asymmetric encryption strategy, so you can control who has access to what. Some nice benefits of these, kind of, to cheat a little, same advantages of the previous strategies, that you're decoupling your application from it, and so generally they don't have to be terribly aware of how this is working. And this one's a little bit of a stretch, I realize, but you get a sort of implicit audit of the secret itself, in that, assuming you don't have Git history rewriting enabled, or you haven't disabled it, you're going to at least get an auditing of what's changed, which has some value. However, these tools also have a lot of challenges associated with them. They're almost never a terrible sort of atomic building block, but they don't give you much. And what I mean by that is things like secret rotation. If you want to do key rotation, you're pretty much on your own. If you want to minimize data at rest, as we talked about before, the artifacts are likely going to be delivered, and you're not going to have a way to you could delete them. I mean, you spin up an app, delete the secret. You could do that, but again, you're not. That's something you're going to have to layer on top. And I put auditing as an advantage on the last slide, but a little weak, because with these secrets, you care much more about access than you care about change, and you get nothing, zero. You have to layer something on top. And because, for the same reasons we enumerated before, you have not solved the bootstrapping problem. However, it may be better than the world you live in. So here are some of the tools I surveyed. I've done some kind of, in some ways, moderately deep dives on some of these tools. Some of them I've used in anger. Some of them I admit I have not. So I'd be interested in hearing about experiences with them. I won't go into depth, but the short version is that Black Box, it's one of the strengths. It supports a wide range of SCM tools, so Git, Perforce, SVN, Mercurial, and has a Puppet integration. So it's a GPG-based tool. GitCrypt, very similar in many ways, except obviously it's Git. Also GPG-based. And then Transcript, which is, again, similar, except it's OpenSSL-based. And at the end of the day, these are all pretty similar in functionality and usage. For more details, go to the little website I've created. I've started enumerating those notes, or dive into the raw notes and see what I found. I also did a quick look at Trousseau and GitEncrypt, which have been around for a while and look like, and someone can tell me if I'm wrong, it looks like the projects are kind of quieting down, not seeing a whole lot of activity. So and there's probably more in this category, but these are the ones that I'm familiar with. Moving on to the next category is orchestrator encryption tools. If you're already in this world of build, test, deployment automation, you'll be familiar with tools like Chef, Puppet, Ansible, etc. And most, if not all, of these automation tools have some level of secret management baked in or available by extension. So there's some nice things about these tools. Because they're automation tools, because they're provisioning tools, automation is a priority out of the box. This is not something you have to wonder whether it supports automation. It will. And if you're an organization who's already, say, a chef shop, the workflow is going to be familiar, and it's something you probably want to examine. But the weaknesses, honestly, are pretty much the same as the previous set of tools. They function in the same way. They don't help you much with the bootstrapping problem. Plus, you've got this vendor lock-in possibility. So which one to go kind of depends on your environment and whether your environment is supported in a good way by these tools, or if you're going to have to probably build something on top yourself. But the major players, and your mileage may vary a bit. These tools are not all the same. And I don't go real deep in these either, even on the website, because they kind of all function as a class. But your mileage may vary insofar as some of them, for example, only support shared secrets versus asymmetric encryption. And to me, that makes me a little uneasy. I find it a little restrictive, but sort of what your tolerance level is. So Hiera, YAML, and Black Box are both for Puppet houses. Yes, Black Box, same Black Box we saw before. Hiera, YAML is asymmetric encryption. Black Box actually will do either because it's GPG based. Chef has encrypted data bags, which is symmetric. Chef Vault, well, I think Nordstrom has layered that on top, and they've added asymmetric encryption on top. And finally, if you're in an Ansible world, at least as far as I saw, you are pretty much going to be using either their built-in symmetric encryption, or you're going to have to do some sort of command line or integration of your own. If anyone knows of any other tools for Ansible, I'm interested. So that's kind of the tool set if you're at this first turtle, so to speak. And how you decide which strategy to use depends, I think, pretty much on whether you're already heavily in an orchestration world or not. If you are, at least examine that tool set first. But there is a grander vision possible. So let's say you want to move beyond this stage. Let's say your secrets are well encrypted, you have decent operational strategies to protect your instances, but you want to further minimize your risk. You're ready for the second turtle, not surprisingly. Let's say as a secondary set of goals, you want to have a more rational and a more compelling, let's call it, key rotation strategy. Something beyond, oh, the keys have been compromised, we better rotate them. Let's say also you want to try to start limiting those secrets at rest. So some of the strategies we mentioned before could work. You could certainly deploy out new keys as needed from your orchestrator. You could also push secrets to your application instances, and as I mentioned before, you could delete them once the app is started. That creates some interesting problems sometimes, but I think it's a viable strategy. But you may want to consider a third option at this point, and that's application pulling secrets. So implementing your own endpoint to do this is a possibility, and in fact wouldn't even be that hard, but quite honestly, implementing an endpoint that returns a couple of bytes is not the hard part here. You still need a way of managing the secrets, of validating client requests, et cetera. Developing the service is the easy part. So what are these services that support this strategy? Secret services. In other words, using an authentication mechanism, a person or a service identifies itself to this endpoint and can fetch secrets from it. So policy determines whether or not access is granted. A lot of strengths in this. There are also a lot of weaknesses, you'll find. But this is a much more compelling strategy to avoid secrets at rest, because a consuming service simply doesn't have to hold on to the secret. It can dump it and then fetch it again when it needs it. And I think this is one of the top two most interesting things about this as a strategy. It also facilitates rotation because for very similar reasons. You can have a short lifetime of these secrets and get a new one when the existing one is no longer valid, and without deploys, which may or may not be a stressful experience for you. A better path toward compartmentalization, whether it's by app, by node, by whatever, you have a more compelling way to deal with that now. And this is the other thing I'm really compelled by, is ephemeral credentials. So we all know that passwords are awful. Like every security conference I've been to in my entire life, everyone rails against passwords, but you rarely hear anybody with a compelling alternative. Well, this is a step in that direction. It acknowledges that passwords exist. It acknowledges we can't get rid of the damn things, but it also says, but we're going to make them function like tokens. So passwords can be rotated very quickly, and suddenly they're not really working like passwords anymore. So I think this is the real power of this particular deployment strategy. Access policy. So this provides a mechanism, a consolidated mechanism for your organization to define who has access to what. And I want to be careful when I say that, because when people hear consolidated and centralized, they get a little jittery, at least at ThoughtWorks. I don't know if it's like that everywhere. But this helps you create a practice for how to define policies. That doesn't necessarily mean the actual policy management needs to be centralized. It can be, if that's what you need in your organization. But this provides a common interface, if you will, to creating those policies. And finally, and of course, auditing. Because secrets are being requested, you suddenly have a super easy path to know who, at least when they're being requested, and hopefully who. That said, I don't necessarily recommend everybody should rush out and do this right now, because there are weaknesses. And the biggest one is the cost of adoption. Implementing a tool like this, and we'll talk about the players in a second, but implementing tools like this is not easy. I think it's going to improve. I know that there are some pushes to make these things a little more consumable, but right now they're work. Firstly, because they're new, and secondarily because you've suddenly pushed a lot of workload to your developers, which may make the operational people really excited, but there's a lot of opportunities to do it wrong, and there's new APIs to learn, et cetera, et cetera. So there's a cost, a significant cost. You've also introduced the possibility of a single point of failure into your system. When you were just sort of pushing things out and they were sitting there on boxes, Well, if your orchestrator went down, at least your services were still running. At this point, if your secret service goes down, you very well may be in trouble, depending on your usage patterns. That's not to say there aren't strategies to mitigate this, failover, clustering, et cetera, but you've still put all your eggs kind of in one basket. And there just aren't a lot of options out there. So this is a fairly new space. I mean, services providing resources, not a new idea. We've been doing that for a really long time. But for whatever reason, this as a commodity is relatively new. So you just don't have you can't do a lot of shopping around. And in the open source world, I was actually all ready to say there's only one option, but I've been warned against saying that by somebody who knows that there's another option. And so we'll talk about that one too. And also, none of this quite eliminates the bootstrapping problem. You still have another turtle. Somebody's going to be requesting a resource, and somebody or something, and you still need to know who they are. So you've just pushed the problem down the road a little bit. So this is the 1.5 players in the open source world anyway. Vault's kind of the one people are talking about right now. I think it's a great team, a great product. However, that barrier to entry is real on this product. It has a lot of integrations that are really compelling. I desperately wanted to push this into a project of a customer I'm working with right now, and very quickly looked at their whole threat model and said, no, I'm not going to do that. That would not be worth the cost. So that'll happen. And so be prepared to examine it and say it's not worth the cost. I think that's a valid choice. A nice thing about this is its integration with Postgres, MySQL for ephemeral credentials, on-the-fly generation of IAM roles, et cetera. There's a lot to like here. It even has a couple of interesting attempts to solve the bootstrapping problem. Getting there, not quite there. So the other player I wanted to mention is Kiwiz. So the reason I kind of, was ready to dismiss it is when I gave this a test run, I simply could not get it to work in a production-like environment. I could get it to work in sort of a development environment. When I made that switch over to real keys, a real sort of rational key strategy, I could not get it to work. And I believe the last thing on their user group is like 2 months ago of me asking, has anybody succeeded in doing this? So to me, that said, this is not viable for anyone outside of Square. Now, what I heard today was that there's a chance that one of the original developers may re-engage it from his new organization. So this thing looks really good on paper. So, and it's much more easy. It's much more, what's the word I'm looking for? It does less than Vault, but in a good way. In other words, it's a little more targeted. And so this could be a good intermediate if it became a little more operationally viable. So hopefully it will, and there'll be a little more competition in the space. But I encourage everybody go out and write one of these tomorrow. So at this point, I think at this point it's safe to say if you're at this second hurdle, the SCM encryption tools are kind of off your radar. And even if you're using one, you're going to be building so much on top of it, it doesn't even count anymore. So you're these are the two strategies I'd be mostly looking at. But think seriously what it would mean to push a mission-critical tool into your network like a Vault, and what it would mean if that goes down. Really think about it and be brutally honest with yourself as an organization, because you need a really good story for failover and clustering. And if this thing goes down, like one of the features / problems with this thing is if it goes down, it takes multiple people. It's like the keys on nuclear launch codes. It uses key agreement. So make sure you can always get at least 2 people on the phone, or you're down. But it's worth a thought exercise to decide if you can afford that. So we're going to go to the third turtle. Things are going to start getting fuzzy, I admit. But let's say you're approaching that theoretical nirvana, and you want to move to real, true ephemeral credentials. You've been thinking about it, and you decided the only way you are going to prevent someone from owning your boxes is by simply not allowing anyone to have access to them at all. So you're shutting off SSHD. You're going to work in strictly immutable infrastructure, and you're going to be completely credential-less. And I use that word knowing it doesn't mean you don't have credentials. It means you're not handling credentials. So because a credential you don't have is a credential that someone can't steal. So again, we've pushed sort of the SCM encryption off the side of the slide. Orchestration tools are starting to not quite cut it because just like before, you're layering so much on top of them. That's not even your primary strategy anymore. Secret services will accomplish a lot for you here, probably not everything. But the question marks are an acknowledgement that I'm not sure what the right approach is here. You're probably going to be doing a lot yourself. I've been hearing some interesting things at this conference about how people are tackling this. You want to look more into things like IAM roles. I love IAM roles. I think it's a great thing from a development perspective. They're extremely powerful. I can define permissions at the level I want to, but of course they only work if I'm in AWS. And secondarily, they don't do much for me if I want to control access to my own resources. And I'm waiting for that announcement, right? I can't imagine they're not going to want to sell me that at some point. But if I have a service and I want to use an IAM role to control access to it, currently the quote best practice on the AWS blog is, oh, you just throw secrets into S3 and control access to that. And that's one checkbox away from the internet. So that makes me really nervous. We actually thought about that briefly on a project I did and said, nah, just too easy to mess that up. So I don't think that's a compelling strategy. But I'm sure it's coming. It has to be. And if it wasn't before, it probably is now. So, and my hope is that there's a new crop of tools on the way. But this is sort of the edge of the road from my perspective for sort of the layperson. There's not a lot out there unless you have the resources of a Netflix. So a couple of final thoughts before opening up to questions about the big picture. So this is, I think, a fairly typical scenario. So I've got a build server. It's publishing artifacts to a repo, and I have a orchestration server, which is pushing orchestration packages to a deployment node, downloading app packages. This is sort of the pre-immutable infrastructure world. Getting my secrets via this deployment package. It is decrypting the secret on the box. I decided I need that level of compartmentalization. Starting up the app. I'm going to be responsible. I'm going to delete my secret and say, if you want to restart, you're going to have to redeploy. I don't think that's too bad. That dotted line, that's my trust boundary. And sitting there outside of it is my artifact repo. And it's all well and good to say that would never happen, but I have definitely seen this. I've lived this, so this is very near and dear to my heart. All the security in the world for key provisioning doesn't matter a damn if you can't trust the integrity of your code, or if all your users have root access to all application instances. And that is not to say those aren't solvable problems. They are certainly. You could have a build server signing artifacts and your orchestration packages could verify them or something like that. Or you just simply prevent root access on your boxes but with immutable infrastructure. My point is not that the problems don't have solutions, rather that you have to take a systems view of this stuff and you need to have a more comprehensive threat model. Do not think you can shove any of these tools in your environment and you're going to be safe. It simply doesn't work that way. I'm probably preaching to the converted, but I think it bears repeating. So in short, how do you find this last hurdle? Well, you can't eliminate the bootstrapping problem, I would suggest. But you can isolate it and have tactical human intervention. So for aspirationally, you can have nearly completely automated deployment processes that require approval via credentialing, sort of big red button, and auditing. And there is not going to be a one-size-fits-all. Yes, it's one of those talks. There isn't a one-size-fits-all solution. And this last point is probably the most important. You want to take small steps. The tool space is still pretty immature. If you're greenfield, maybe you can shoot a little farther, but for the most part, most organizations are going to want to just take a step and iterate, see where they are. And the more they're auditing, the more they're collecting, the better they will know where they are. But these tools are, particularly as you get more sophisticated, they're challenging to set up. And as fantastic as a tool like Vault seems to be, it's a major cost and probably not worth it for most organizations, I hate to say. So I think I got through it all, speaking rather fast. So I guess that means that there's a little more time for questions. Feel free to step up to the mic if you have anything, or if you'd rather just approach me after, that's fine too. And please, I'm going to try to keep this site somewhat up to date. I'm going to continue this work because it's very much a work in progress. And there's more open source tools like popping up all the time. So I want to try to keep a running list, and I want to hear feedback from people who've used some of these in anger. Like I said, I've used some and not others. So I'd like to hear the kinds of hurdles people have encountered and the solutions they've come up with to try to make up for those hurdles. Thank you.
I have one question about solutions that you didn't mention, but it looks like they're very promising, and some companies are using them. The one is called CryptDB by MIT.
CryptDB?
CryptDB. And the second one is ZeroDB.
Mm-hmm.
It's like created by some folks. Have you heard anything? Do you have any comments?
I don't actually. What sort of
so like this is
type of tool are
yeah, this is what the kind of idea that they use. They're actually saying, we don't want even to share our keys with the server. All our encryption will be done on the client when you call your SQL query. And this is when they will encrypt everything before the data is sent to database. And the same is true about the decryption process. At SQL query, when you query the data will be decrypted at that level and then returned back to the client. So do you have any insights?
I think I'd have to think about that more, but it doesn't seem dramatically different than having an encrypted payload in a database. I mean, I'm not exactly sure I see the difference between that and simply encrypting all the payloads in the database and decrypting on your client. But
the difference is that like your client, for your client, the encryption is transparent. You don't need to care about that.
Oh, I see. It's just
everything
simply
is implemented as like
use.
at SQL level API.
Yeah, it's conceivable. I don't actually. So, I'll have to take a look.
I will send links to you to
Please
this email. It would be great to see.
Thank you very much.
Another question. Have you considered any HSM modules?
So I consider them heavily. In fact, when I was trying to decide whether I wanted to try to cram even more into this and talk about HSM, but to me those are sort of related but independent concerns. Like some of these you can actually back with an HSM. I think Vault is not a terribly compelling story for that right now, but I think it's going to come. So even with an HSM, you haven't quite covered the surface area of what these tools are trying to accomplish. I think certainly an HSM is a good idea to back, your if you have signing keys for your certificate authority and things like that. But again, that doesn't solve the problems when you're dynamic. And I'm hearing Netflix has a pretty good solution for that. But yeah, no, good idea, kind of unrelated concern. Or related, but not the same concern.
I have a question.
Yeah.
How does the application, if you're using the service, the security service,
Mm-hmm.
how does the application identify itself to that service? And that's a turtle, right?
Yeah. Oh, absolutely. I do not deny this. This is why the bootstrapping problem has not been solved at that point. So
well, let me ask a different question. If the bootstrapping problem can't be solved,
mm-hmm.
what's the point in adding more turtles?
Because, so for their own sake, zero. But just because, so I talked a little bit about not letting perfect be the enemy of the good.
Right.
If you're very fragmented, reducing your attack surface is obviously valuable, right? So if you can make it such that a very small number of people have a small amount of very heavily audited access, that's a very different story than it's kind of like free-for-all. It's always a middle ground, right? You're right. You can't actually solve it, so it's about finding the appropriate middle ground.
Okay.
So that's sort of a hand-wavy, fluffy answer, I know, but I actually believe in that deeply. And so, for example, let's say I want to be able to dynamically push secrets out to a box in case that they change. I could bake a private key into an AMI and then know, or even if I'm really ambitious, bake private key generation into an AMI, although then you have a totally different problem. But I can push secrets to that. I still have the problem of that first initial secret, but I'd rather have one person have to deal with that first secret than have to deal with it every time I need to push a subsequent secret to it. So you've reduced your surface, you've made it a little more manageable. You haven't quite, again, you have pushed the problem down a little bit, but you've made it a smaller problem. And I think that's the best we can really aspire to.
Sure. Can I ask another question?
As far as I'm concerned.
This is, so we've been trying to do this, and we sort of jumped around developing in-house a lot of these kind of solutions. Another problem that we had is that some of our applications use some quite legacy resources, like file system that's managed by Active Directory, or you know, SQL Server with like static passwords. I mean, it seems like you're creating a lot of complexity to try to make all of those ephemeral.
Yeah, I mean, again, some situations you're simply not going to be able to do it, and those are probably the situations where a secret as a service is not going to work, at least not for everything.
So this is the situation where it works really well, probably, is when you have like a service layer protecting all of your resources.
Absolutely. If you're comfortable in a world of microservices already,
Right.
probably worth a look. If you're dealing with a lot of legacy where you simply cannot, for example, someone pointed out to me the other day that somebody may have a connection pool that doesn't have sufficient flexibility to be able to grab secrets on the fly.
Right.
If you have a legacy app that works that way, you could do it, but you have a rewrite ahead of you. That's less extreme than the case you're talking about, but there are definitely places where it is not going to work. Or it'll work, but it'll be very painful.
Thank you.
Thanks. Thank you, everybody.